Okay, let's talk about hashing tables in A2 computer science. Actually, we were when we were having a previous class or the previous recorded lecture, in which we were talking about random filing. So random filing uses hash function frequently, and the students were asking, sir, if you can explain us the hashing algorithm once again. So let's get done with the hashing algorithm. Once again, let's try to solve one past paper questions relevant to it. Let's discuss how the hashing algorithm actually works. What is the science behind it? All right, so let's talk about it. Okay, hashing algorithms. Or to be precise, hashing buckets. Let's discuss it in a most simplest way. For example, if I have a number of what we can say is records, and it could be number of records, and I just want to store them in a computer memory or some ADT or maybe a file, just like we did the random file, and it has different addresses, something like that. Okay, and if we want to hash them inside this memory, in a way their value should be dependent and they should be randomly on the basis of their value stored in this computer memory. So we're going to have a hash algorithm. It could be anything. Hash algo, let's say if we say these are the k values and k divided by some value m, and we want to do the mod thing, and mod with, let's say 5. Okay, and the value of k0 is, let's say it's 93, and m is fixed, it's, let's say, um, sorry, let's say this is k, this is mod, and this is m. Let's keep it as simple as it can be, and the value of m is 5. So in this case, it will become, for the value k0, 93 mod 5. And we know that how the mod function actually works. 93, 5, and 90 and 3 will be the remainder. The mod always return the remainder. So the remainder will be 3, and this 93 will be mapped to this memory location. That's quite easy. So this is how it is. So this 93 is hashed. This is the hash algo, and it's mapped into this memory location according to its value. For example, it's 91. So I guess you already have an idea. If 91 will be mod with 5, 1 will be the remainder, and it will be mapped here. What if? What if that there's another value, something like that, 53, and when you do the 53 with 5, it will again going to return 3 as a remainder. Now when 3 is returned in this case once again, and we know that at memory location 3 the value is already stored, what we will going to do, we will going to redesign our algorithm in a way that if we are going to store on a memory location, on that memory location there is something already present there, we will increment, we're going to increment the, let's suppose this is our index, so we're going to increment the index, index, we should not write down here, index index plus one. If I'm calling this whole thing as an index, so if there is something already placed there, if the value here is actually, I just forgot to tell you that mostly the data elements they are like if it's integer based, they are like initialized with zero, and I can simply say that if this place is not zero or it's greater than zero, it's mean then I cannot store the value here. I'll do the increment first, and after incrementing, I'm again going to check that if something is there or not. If there is zero, anything that like it's not greater than zero or it's not is equal to zero, it's mean there is nothing is equal to zero. I'll store my data here. So this is how the hashing algorithm works. And there could be one another thing. For example, there is some other value k3 and it's 73. In this case, again, the remainder will be 3, and we will come up to this place once again. Okay, and it's again keep incrementing until it find the empty space. It will store it here. Okay, this could be the situation that we have some value stored here as like this, and some value here as this, right? Or maybe some value is stored already here as this, and we just have some value like let's call it anyhow. Let's fill this up as well, and we have some value like 54. We know that the remainder will be 4. Okay, and this is the place where this value should be stored, but this place is already occupied. We increment places again occupied, we increment places again occupied, we increment places again occupied. It will keep incrementing it increment places again occupied, and the maximum position of this index is also achieved. Now what to do? We're going to do what? We're going to again set the index to 0. If the value is equal to the max value, okay, then what we're going to do, we're going to set the index to 0 again, so it start searching for the empty place from here. Again it's occupied, +1, again occupied, it's +1, and here the value it will going to be stored. So this is how our hashing algorithm work. This is how we insert the value inside the hash. After inserting, we should also know about there are two main features regarding hashing algorithms: insert and search. Now this is the description. We need to see how the program code actually works. You can go to GitHub. After going to GitHub, you can go to E2. In E2 section, you can go to hashing buckets. This is the program. You can simply click on it. After getting to this program, you can simply copy the program and put it into Visual Basic. This is Visual Basic 2010. This still works like a charm. It's lightweight, and it just get the job done. Okay, Jana. If this is our program, okay, and here it's a small little program, so we don't need to input much values. The stdarr is the array where we were going to store our values. Let's try to um, it will be better that, yeah, something like this. Okay. Hmm. So this st rec 3 uh, stud array, let's call it student array, has three elements. What color is this? Okay. And the uh, what is the length? 0 1 2 3. Yeah, 0 1 2. Seriously, 0 1 2 3. Okay, let's redesign it. Okay, so this is the name of this array is studarr, and that's the reason that we are using this for loop from 0 to 3. And here we are just taking input and calling insert hash to move that value inside, to, to insert the value inside this studar. Okay, let's try to run the program line by line. Okay, so let's give this value 33. um, Inside RAC33, insert hash will be called. We come down here, insert hash, rec key will going to receive that value 33. Has been passed here to this procedure. Sub insert hash is not returning anything, it's a procedure. Hash key is equal to, now this hash again, this is again some procedure or function, it's a subroutine, and whatever the value that will be going to be returned, it will be stored in this variable. Now by looking at this equation, I can tell this hash is in function because it's definitely returning some value which will be received by hash key. So now this hash will be called. Two things are being passed, two parameters. Rec key has the value 33 and 3. This will be the top position, the maximum position of the data structure which we are using as an array. Okay, so it just jumped down here to the hash function. This 33 is received by this variable keyval, the 3 is returned by the max position variable, and this is a small hashing algorithm, you can say, which doing just which generating the value every time. Okay, so key value is 33. It's getting mod with the max position plus 1, 3 plus 1, 4. So if 33 is divided by 4, 3 should be the remainder. So index position. Oh, it's 1, 42. My bad. So index position 1 is returned. This index position is returned, which will be cached by the hash key here. So 3 has been passed. Now the very first thing that we need to do right now, in hash key we have 1. We have 1 in hash key. It's just basically working as an index. And because it's the very first value, initially all the array elements have 0 inside of them. So, but still, we're going to have this check, this particular check from here till there. So before inserting the value inside the array or the data structure, we will going to check that if the place is available or not. So this student array hash key, right now in hash key it's 1. It will going to check that if the value there is, if it's not 0, it's mean if it's not empty, then we will going to increment the index, and we're going to keep incrementing the index until the max position reached. When the max position will be reached, we will going to set the hash key to 0 again, and again we're going to start. finding the suitable place. So right now here at hash key at student ARR 1, because in hash key it's 1, there is nothing, it's 0. So I'm going to put the value here. The hash key was, I guess it was 33, right? Yeah, it's 33. So 33 is stored here. And right now we can go there and we can see that um, 33 is being stored in student array. Okay, so next step, it's been called again. Let's say 20, and this is the same pattern that it will be followed. Probably 0 will be the yeah, index, and at student array 0, 20 will be stored. Okay, 20. Let's give it some other value, something like 23. Okay, now 3 will be the index, it will be returned, and it will be stored on third position, precisely here, 23. Okay, uh, okay, let's insert another value, 15. Okay, and let's see what happens now. It's been called, we came down here, and the index position is generated as 3. We went up. Now something special is going to happen. Student ARR hash key, inside hash key it's 3, and in student key hash key the value 23 is already stored. Even the program is telling us, when I'm hovering my mouse over it, it's telling me that student array hash key means 3 has already a value 23 inside of it. So definitely it is not 0, it will go inside, it will increment the hash key, it will become 4. Now 4 is larger than 3, means the fourth index, the maximum index is 3. So if the index, it's, if we are like at the end of the array, we will set our hash key or our index to 0, again, like this, and we went up again. Now as student array 0 already has a value 20 inside of it, again it will be true, it will go inside, it will increment the index, and it will check if the index is greater than 3. It's not greater than 3, it will go up, it will again check. Now student array 1, it also has a value inside of it, it's 33, you can see there. Okay, so index will be again incremented, and it's not greater than 3, it will go up, and student array 2 has no value inside of it, 0, finally will come out of the loop, and the incremented index to the value will be stored there. So the value 15 will be stored here this way. So this is the insert function for the hash key, and this is how it's working for the insert function. The similar way, if we need to search something, we just need to generate the hash key in a similar fashion. We're going to call the hash. The hash will going to generate a random, according to that, the value of the key. It will going to generate the index. We're going to come back. We're going to compare If the value will be compared, we'll say that the value has been found, and if it's not, we're gonna say it's not found. That's it. So and this search algorithm basically is returning um, 0 if the value is not found. It's if it's if in greater than 3, or there is one another condition that was there. Rec key, yeah, it will going to return uh, if the value will be found, it will going to return us the index of that value, and if the value is not found, it will going to return us 0. All right, so this is the search hash. We can implement that as well. um, let's try to search the record into the search record key. Let's try to find out 23 if it exists or not. um, Search hash is being called. We came down. This hash function will be called. The hash key is right now, it's actually we're trying to search 23, and this 23 is being sent down here. The value that we want to search, the max position by default 3, we know it. The index will be generated. All right, will come up, and we'll compare the hash key. This hash will going to return us the index 3. And now we will try to find out that if the student 3 is not is equal to 23. If it's not is equal to 23, uh, actually surprisingly at certain hash key 3, it was is equal to that and it's just returning back. The search algorithm works in a similar way, in a similar fashion, in which we can see that our insert algorithm works, because sometime when the key is generated, we go back that key, just like we have seen that the key was generated and the index was like it was incremented. Sometimes what happens that the same way in searching we have to do the similar thing. We have to search the particular element inside the array through index, and we need to increment that as well. So right now luckily we just come to uh, get our results immediately. X is equal to 0. If it's 0, then it's been not found, and if it's something else, it's been it's found. Yeah, it's found, and that's it. This is our hashing algorithm, and this is how it works. Let's try to discuss this hashing algorithm quickly through our past paper question. um, So on page number 89 of your past paper booklet, paper 4, the question suggests it's the hashing uh, array is declared with the help of an UDT. The hash table is to be implemented as a one-dimensional array customer with the elements indexed 0 to 199. So we just really need to pay attention to the question closely. The procedure to create a hash table will declare and initialize. So this hash algorithm, this create hash table, will not only going to initialize, it will also going to declare the variable, the array as well. 200 records with customer ID field. The customer ID field is set to be 0. Okay, so we need to do this. Type customer record. This is the user defined data type. We need to declare and initialize the array. Definitely need to be declared first. So declare one dimensional array customer, and this customer array it has elements from 0 to 99, 199, and the data type of this will be customer record. Why customer record? Because they already have told us that um, in the customer ID field in each record. So this customer can only have a field customer ID if it's declared as customer record. All right, once we're done with this, now what we need to do, we need to initialize all the elements, I guess, and we need to use the for loop for c is equal to 0 to 199. Customer dot customer ID. You guys need to know the UDD before what I'm doing right now. Basically, this customer is declared as a customer record, and this customer record is a user-defined data type. In this customer record, we have two fields, the customer ID and data. So every element of this customer array will be divided into two parts. One part will be addressed as customer dot customer ID, and the other part will be mentioned at customer dot data. So this is how it will be done, every single element of this customer array. So we just need to move the zeros at the customer ID portions. So customer to customer ID 0, next, end procedure. That's it. So 4 marks right there. After that, we have declared our array for the hashing buckets, and we have also initialized the customer IDs with 0. Okay, so the next is the hashing function hash exists, which takes as a parameter the customer ID and returns integer in the range from 0 to 99 inclusive. So this is just the hash function that we have just done here. There's no big difference. The procedure insert record takes a parameter as a parameter the customer record to be inserted into the hash table. The procedure makes use of the function hash. Collisions will be managed using open hash. Okay, just like the open hashing we're talking about, if there will be collision, index is equal to index plus 1, and if there is a max size, we're going to get started with the 0. This means a collision is resolved by storing the record in the next available location. The procedure will generate an error message if the hash table is full. So in this solution, if the hash table is full, we will be able to reply the answer as well, like it's the error as well, if the whole hash table is full. So this is the procedure. Procedure insert hash, it's receiving a value new customer. Table full is by default set to false. Generate a hash value. How to generate a hash value? We already know that how to generate a hash value. We just need to call the hash function. We just need to call the hash function, just like here. This is what we're doing, right? We're calling the hash function. We're passing a value, the max position, and the hash index will be received. So this is the index. They're using it as an index, and we just need to call the hash. They can name their functions and procedures differently. You just really again and again refer to the question, but they have already mentioned that the function is hash. So hash. What value need to be passed? The procedure function a collision upon the procedure insert record, the means collision, the hashing function hash exist, which takes the parameter customer ID. So customer ID is being taken as a parameter and returns an integer. Okay, so it's mean this hash function is going to take customer ID cannot be written down like this because it's part of the customer record. So customer ID. And there is no max position required. This is the only one single parameter they have already mentioned. Takes a parameter customer ID, and customer ID being the part of customer record. This is how it's being done. In pointer index, we're just assigning this index to pointer. That's fine. Find the free table element. We already know that. While we know this because of this condition. While student array hash key. Here, what is the name of the array? I'm just forgetting. What is the procedure insert hash? The name of the array is customer. Yeah, customer. So while customer dot customer ID, find a free table element pointer, and we need to write down here pointer dot customer ID is not is equal to 0. Pointer is equal to pointer plus 1. Wrap back to beginning of the table if necessary. If pointer is greater than, what was the length of the array? The top maximum length of the array is 0 to 199. Okay, it's 200 records, but 0 to 199. So the max position is 199. If pointer is greater than 199, so we're just following this program that we have learned. You can see that the insertion part of it, hash key is generated if this thing is not is equal to 0, plus 1 if it's greater than 199, then we set to 0. So pointer will become 0 again. Check if back to original index. Okay, now because we have to include one more thing which is actually not included here, because there were 4 records and we're using for next loop for 4 records. We didn't require to needed to be checked that if the array is full or not. But here we need to include the check if back to original index, its pointer is equal to 0. If it's back to its original index, mean if pointer is equal to index, then table full is equal to true. Okay, there is another if here. Why it's here? Okay, because if the index pointer is equal to index and table is full, if table is not full, then we will, because we of course we also have to do this in the main part, we need to include the value inside the array. So we haven't done that yet. So if customer if not full, if not table full, then after this we will going to write customer pointer new customer. So the whole new customer will be mapped into this customer because both of them have the same data type. So this is the insert function for the procedure, for the hash table, which was quite easy. If you will be executing this code once all by yourself, after that you will be able to solve this question quite easily. And after that there is a search a code, which is again, if you're going to put down with this program, you will going to learn it quite easily. I just wish you best of luck with this hashing algorithm. Please do let me know, give me feedback, especially regarding the random filing, and let me know which new topic that we need to pick. Probably from ADT, I guess it's a linked list is the program, the programming of the linked list that we need to finalize. The binary tree is done, the stack and queue is done, the programming of the linked list is required to be done. Okay, all the best. Adios.